We'll first introduce our first speaker. Thank you so much, Shippo. So with that, we'll first introduce our first speaker for the evening, Ms. Karen Klimowski. Karen Klimowski is the Senior U.S. Foreign Service Officer and is currently the Indo-Pacific Coordinator and the Acting Deputy Mission Director at USAID India. Prior to joining USAID India, she served as a Foreign Service Officer with USAID in Philippines, Uganda, Kenya, and Indonesia. She's also worked with non-governmental organizations and California county government. So it's a great pleasure to invite Karen for delivering the welcome remarks. So over to you, Karen.
Great. Thank you so much, Monali. And namaste. I'd like to wish everyone joining us from India a good evening, and from those in the US or other parts of the world, good morning or good afternoon. I am pleased to be here today with Joint Secretary Devangan from the Ministry of Power, Mr. Ramesh Babu, the Director of Operations at NTPC, esteemed panel members, and honored guests. On behalf of the United States Agency for International Development, I'm delighted to welcome you all to today's event. It's heartening to see everyone here virtually, and I'm looking forward to today's discussion about India's fast-changing energy landscape. The world is moving towards a renewable future, and India is leading the race. Even during the lockdown, in an auction conducted by the National Hydropower Corporation, tariff bids for solar capacity were markedly lower than the 2019 average. Investors clearly have faith in India's vision. The government of India plans to deploy 175 gigawatts of renewable energy by 2022. Prime Minister Modi more than doubled this target at the Climate Action Summit in December of 2019. Flexible operation of coal can be an important strategy for India to achieve its targets. Indian coal plants can play a crucial role in supporting the grid and accommodating renewables through flexible power generation. The United States government is happy to contribute to this agenda through USAID's bilateral program with the Ministry of Power called Greening the Grid, a key activity under USAID's Asia Enhancing Development and Growth Through Energy, or Asia EDGE. This initiative aims to support sustainable and secure energy markets in the Indo-Pacific region. In partnership with the Government of India stakeholders, USAID is testing a range of innovative technologies and solutions to help in large-scale integration of renewable energy. This is being undertaken as part of Greening the Grid's central component called Renewable Integration and Sustainable Energy, or RISE. One of the key pilots under the GTG-RISE Initiative is flexible coal-based power generation. To execute this pilot, USAID partnered with India's largest public sector power generation utility, NTPC, or the National Thermal Power Corporation, and the Gujarat State Electricity Corporation Limited, or GSECL. As part of the pilot, Greening the Grid RISE studied the technical preparedness and cost implication of flexible operations at selected units. The low-load test runs conducted provided evidence and basis for the nationwide scale-up. These interventions helped in pinpointing specific recommendations on operational practices, procedures, and retrofits required for flexibility. The pilot helped for their coal fleet and prepare a business case for policy and regulatory changes. Over the last 4 years, several operator training and capacity building workshops were organized, including visits to utilities in the United States. Currently, USAID is partnering with another state generator, Karnataka Power Corporation Limited, to scale up the work on flexible generation. Today's webinar is aimed at presenting some of the highlights from the pilot and stimulating a high-level discussion around policy implications and the business case for supporting flexible coal generation. It also marks the public release of 2 very important publications. The first publication we are releasing today Transition Towards Flexible Operations in India, is a summary report on the pilot's activities, achievements, and recommendations. This is an important work that will inform India's strategy to address variability in renewable energy generation, as well as set a benchmark for the entire South Asia region. The second publication released today is the recipe book for flexibilization of coal-based power plants. Its author is our very own Mr. Sinha, the senior advisor with Greening the Grid RISE. The book promises to be insightful and interesting as it documents Mr. Sinha's personal journey and his experience working at NTPC, as well as his collaborations with a number of partners such as USAID and GiZ. The insights from the pilots and the reports offer important inputs as India strides forward on its path to decarbonization. USAID is proud to partner with India in its energy transformation and efforts to build a robust and resilient power sector. We will hear more about this journey and the path ahead from Joint Secretary Devangan. Mr. Devangan, thank you for your time and support and our joint efforts in the power sector. We are proud to partner with the Government of India on its journey to a high-performing, low-emission, energy-secure economy. I am also grateful to our pilot partners, Mr. Ramesh Babu from NTPC, Mr. Panaraj from KPCL, Mr. Baxi from GSECL, in addition to all your team members for making our partnership a success. I would also like to thank our esteemed panel members, Dr. Dam from GiZ, an important partner of USAID, Mr. Malik from CEA, and Dr. Ten from VGB. Together, they bring in a wealth of experience in the sector, and I, along with many other participants, are looking forward to hearing from you all. I would also like to congratulate the Deloitte LLP and the implementing partner, who is the implementing partner for Greening the Grid RISE, for organizing this seminar. Lastly, I would like to thank all of you for joining us today, and I wish you all the best in the upcoming discussions. So thank you.
Thank you so much, Karen. Thank you for your words. We'll now move on to the next speaker for the evening, Mr. Ramesh Babu, who will be delivering the opening remarks. Mr. Babu is the Director Operation of NTPC. He joined NTPC as an executive training in 1987 and has been with the organization since then. With more than 32 years of experience in managing large power stations, he has a whole range of experience. Mr. Babu also was the director before becoming, before appointment as Director Operation, he also served as the Executive Director to the CM. So over to you, Mr. Babu.
Thank you, Monali. Good evening to all of you, all the panelists and the attendees. I see around 115 attendees and 18 panelists. Good evening to Sri Devangan Saab and Madam Karina Klimovsky. I am delighted to be part of this GTG RISE webinar that is creating the grid and renewable integration and sustainable energy. As you are aware, these are difficult times. We are hoping that a miracle will happen and the vaccine will be coming out very soon so that the COVID pandemic will end. We all hope and wish the worst is already over behind us and the life will be back to normal very soon. In India, in the recent last 1 month, the demand for electricity is growing and it is increasing steadily, and with the improvement starting of the commercial and industrial activities within India. As all of you are aware, that 175 gigawatt of renewable power, that will be the amount of total renewable power that will be within the grid by 2022 in India. We do not have enough idle capacity, gas or pumped storage units to balance the variations of the renewable generation. So therefore, the thermal units need to back down and support the grid whenever there is a large renewable generation. So it is not uncommon in the grid right now to have a variation of 20 to 30 gigawatt during the day, and we are increasing at the rate of 5 to 7 gigawatt per annum is the increase in the variation. So this is a major area of concern for us, both for the thermal generators as well as for the grid operators. How do you maintain the grid stability with such large renewable penetration to the grid? And since all our units were initially designed for the baseload operation, we need to take some modifications, do some modifications so that they can be made ready for the flexible operation. In this direction, GTG-RISE program has contributed towards this finding the solutions for this large-scale renewable energy integration into the grid. Under this initiative, with the help of USAID, partnering with Intertech, we have conducted a study at 2 NTPC units. That is one at Ramagundam and another at Jajjar, for determining the techno-commercial feasibility and estimation the cost of the cycling of the units for various types of startups and ramping up. Also, with the support of BHL and USAID, we have completed another pilot project for 40% technical minimum load operation with higher ramp rates at our Mauda unit in Maharashtra state. All these studies were extremely useful for us in getting the insights. What are the issues that have come up during this flexible operation? And they would be helpful for us in operating at much higher ramp rates and lower operating loads. Right now, based on these studies, we're actually doing a pilot project at two of our stations, one at Dadri, another at Simhadri, with advanced process control to run our units at lower loads and at higher ramp rates. These two pilot projects are continuing, and we hope to finish them by December 2020. Based on the inputs and the findings from these stations, actual implementing at these two stations, we'll be further going for this implementation of this advanced process control in all our other stations. We would like to express our appreciation towards USAID for the support that it has given to NTPC for hand-holding us in transition to a more flexible mode of operation in the thermal units. I also wish GTG-RISE team all the very best on the release of the two documents today, and I'm sure that the key findings and lessons from these pilot project studies will be helpful to all the power plant professionals in the country. Thank you very much.
Thank you so much, Mr. Babu, for your kind words. I will now introduce our special guest for the evening today, Mr. Vivek Devangan. Mr. Devangan is presently assigned as the Joint Secretary, Thermal and International Cooperation, Ministry of Power, Government of India. During his illustrious career of 25 years as an IAS officer, he has held various positions in the area of finance, power, commerce and industries, economic affairs, petroleum and gas, and so on. I'm extremely delighted to welcome you to deliver the special address, sir. So over to you, Mr. Devangan.
Good morning to my colleagues from USA and good evening to my colleagues from India. I'm extremely happy to be part of this event on transition towards coal-based flexible power generation in India, which has been organized under the initiative of RISE, that is Renewable Integration and Sustainable Energy, as well as Greening the Grid program. The Indian power sector is undergoing a significant change that has redefined the industry outlook. The focus has now shifted to having a safer environment along with sustainable power generation. One of the major advantages is that India has vast renewable energy potential of around 1,050 gigawatt, which is largely untapped. It is estimated that solar potential in India is greater than 750 gigawatt and the wind potential is about 300 gigawatt. Considering the vast potential in India, government has set up an ambitious target of setting up about 175 gigawatt of installed capacity from renewable energy by December 2022, next 1 year, out of which 100 gigawatt is planned through the solar energy, 60 gigawatt through wind energy, 10 gigawatt through small hydropower, and balance 5 gigawatt through biomass-based power projects. The target for the solar capacity is to be achieved through 40 gigawatt rooftop projects and balance through utility scale solar plants and ultra mega solar parks. There is already a significant wind power capacity in operation, and various initiatives have made solar power more widespread in India. Due to high thrust on renewables, significant growth has been experienced. The installed capacity of renewable, both solar and wind, has increased from 44.6 gigawatt in March 2017 to about 72.3 gigawatt in March 2020. Renewable power output has limitations. Variability varies from moment to moment. Uncertainty cannot be predicted with any certainty in advance, and concentration during a limited number of hours of the year. Thus, there is a need for the balancing the demand on various time scales for proper functioning and security of the grid. As the majority of the generation is from thermal power in India, hence the support shall have to be provided by the existing fleet of thermal power plants. World over, the energy transition is taking place from coal-fired to gas-fired power. But in India, we do have limitation on the availability of domestic gas, and the imported liquefied natural gas is not cost competitive. The power produced from LNG is not able to compete with the power which is available from renewable sources or through the coal-fired power plant. So therefore, we had to live with our coal-fired power plants. That's why with the increase in share of renewable energy in the grid, we need to have more flexible operation of the thermal power plants. A significant proportion of the older coal-fired plants are based on conventional subcritical technology, which were originally designed and built with steady base load operation. The major change, like operating cyclically daily, has major impact on coal-fired plants in several areas: operation and maintenance, plant life, and economics. Hence, in a scenario of high penetration of renewable, that is 175 gigawatt by 2022, there is an urgent requirement of developing the flexible capability of existing thermal power plants. We had constituted a committee under the chairmanship of CA, that is Central Electricity Authority. This committee was to suggest the flexible power and ramp rate required in the year 2021-22 from the thermal power plants to accommodate renewable energy integration from the plant capacity of 175 gigawatt, so as to maintain a stable and secure grid. The committee was also given the task to suggest a methodology for identification of units for implementation of minimum load operation on priority basis. The committee has prepared a report and suggested guidelines for the flexible operation of the thermal power plants, which include methodology for identification of thermal units for minimum load operation. As per the report, about 67,640 megawatt, that is about 31% of thermal capacity, is to be operated in a very flexible or high degree of flexible mode, while about 70,770 megawatt, that is about 32.6% of the capacity, is required to be operated in flexible or moderately flexible mode. So at least 1/3 capacity should be checked and made ready for the high degree of flexible operation in the event of 175 gigawatt renewable energy addition. As per the CRC norm, the technical minimum for our thermal power plant is 55%. But we also taken up some pilot project. We have been trying to bring down this technical minimum to 40% or about 45%. We had taken one pilot project in association with IGF, and another pilot project has been taken in association with J-Coal from Japan. In order to oversee the implementation of flexibilization and guide the state or central utilities, a committee of the leading stakeholders in power sector, that is NTPC, BHEL, POSOCO, GE, Deloitte, and Tata Power, had been constituted by CA in May 2019. Based on the findings of CA's flexibilization report, the committee shall identify the thermal units in consultation with state and central utilities for flexibilization pilot test. The identified units shall have to undergo the pilot test to ascertain their capability, do gap analysis, and carry modifications if required. So far, 6 thermal power plants, units of state and central utilities, have undergone the pilot test to validate their flexible capabilities, and many more are in the pipeline. For grid integration of renewables, there is an urgent requirement of building up of the flexible capacity in the country. The strategic partnership with US can be a useful platform for conducting the test for ascertaining the flexibilization capability in some of the identified thermal power plants. The strategic partnership with the US can be utilized for the transfer of technology, for developing indigenous capability, for conducting the flexibilization studies, and also acquiring the simulation package. Dynamic simulation can be a cost-effective tool for studying and improving the flexibility in an efficient manner of individual thermal power plants during the fast load changes. These studies shall be a precursor for conducting further tests on any thermal units to ascertain their capability. At the end, I would like to thank US Agency for International Development for their cooperation with India and for organizing this event during such testing times. Thank you very much.
Thank you so much, Devangan sir. Thank you so much for your words. We have a short presentation, a context setting presentation on the two reports before we release the report. So I'll call upon my colleagues Anuj Vashishta, Pilot Manager, GTG-RISE and Director, Deloitte India, and Mr. Sinha, Senior Advisor, USAID GTG-RISE, to quickly make the presentation. So over to you, Anuj and Mr. Sinha.
Right. Thank you, Monali. Thank you all the inaugural speakers to have set the context already. We have 2 documents lined up for release as mentioned by our inaugural speakers, but we thought of giving a gist of what we have, what all we have in the documents. And so it's a short summary presentation about the summary report on the coal flexibility pilot and the recipe book on flexibility that we are about to release. So the summary report essentially takes you through the journey over the last 4 years we had with NTPC and GSECL, where we did the technical due diligence studies, the feasibility assessment at 2 units at NTPC, one 200 megawatt unit at Ramagundam and 500 megawatt unit at Jhajjar, and similar 200 and 500 megawatt units at GSECL's Ukai station. And we were ably supported by our international technical experts from Intertech, Nikhil Kumar, Douglas Hillerman, Thomas Burnett, and other experts from Intertech. And of course, we had our in-house technical expert, Mr. A.K. Sinha, guiding us all the way through the technical due diligence. And during the feasibility assessment, we essentially looked at past 10 years data of operations of these units. And we were able to come up with the attributable cost that would be subjected to these units should these units be running on flexible operations in the near future. And those damage cost modeling studies actually gave us the incremental cost for increased auxiliary consumption, degradation in heat rate, additional fuel oil consumption, and even the ramping cost that would be attributable to a typical 200 and 500 megawatt unit. Having had that cost in place, it was very imperative that we look at how this cost can be compensated because these are regulated plants, how these costs can be compensated. So we presented this to the utilities and to the commissions, and the discussions are still going on, and we see a traction over there. And also then looked at whether this sample size of 200 and 500 megawatt units can actually be look scaled up at a fleet-wide level for NTPC as well as GSECL. So we came up with a strategy for fleet-wide implementation for these two utilities, and then also demonstrated that yes, Indian coal power plants will be able to run on flexible mode by two very successful low load test runs that we conducted at NTPC's Moda and GSECL Ukai stations. And as a scalability effect, we actually looked at scaling this the pilot activities from a demonstration stage to another level, next level. And we have taken up in supporting KPCL's two units, one Bellary and one Raichur unit, in doing similar kind of studies this year. So that's in a nutshell what we did in the pilot. And now we quickly look at the key recommendations that came out during these studies. So one of the key areas that I think Mr. Ramesh sir also mentioned was on the compensation for flexible operations. And this essentially is about the cost that would be attributable to a generating unit if the unit is subjected to a low load cyclic or two shifting operations in the near future. This phenomenon already started taking place in most of the state utilities as well as the central generating utility. And the recommendations that came out in our study was that there should be some mechanism either through regulatory interventions or through a market whereby the generating utility is compensated for the initial costs that are accrued due to retrofits, one-time fixed cost for making the unit run on flexible mode. Also, there should be some incentive mechanism for the new units to take up flexible operations on a regular basis. And of course, the existing units would incur a large amount of operational expenses, be it due to the degradation in heat rate or because of the increased auxiliary or specific fuel oil consumption, and also the ramping cost and the life cycle damage cost that would be attributable to the flexible mode or to shifting mode. So these costs were already presented to the utilities. In fact, CA in its report last year on flexible operations did come out with these costs very clearly on what are these costs on a per unit basis and how these should be compensated for the going forward for the generating utilities. The second element is, of course, the fleet-wide strategy that we prepared. This essentially talks about, and this is not just for NTPC and GSECL, any utility having a fleet of coal-based stations could take cognizance of this fact that not all units will be subjected to flexible operations. It has to be decided on a phase-wise basis. The unit's age, design, make, coal quality, and the operational practices are to be reviewed. We did the exact similar exercise for NTPC as well as GSECL and came out with a phase-wise approach on how to implement various units. We demarcated some of the units might not actually be required to run on flexible operations at all, but there are some units which would definitely be subjected to two shifting, which would definitely be subjected to cycling, maybe to loads lower than 55%, 50%. And that's where essentially the preparatory activities that are required to be taken up from these utilities become very apparent. And the next level of recommendation came on the operational practices, where we came out with specific unit-wise recommendations for NTPC and GSECL. However, there were certain recommendations that would be typically attributable to a 200 or 500 megawatt units across the country, and those generic recommendations find their way in the summary report that we are about to be released. And those range from a wide range of technical interventions that the plants can do, right from nitrogen blanketing or having automated startup and shutdown procedures, or looking at the way the flame scanners are operated, or the coal mills operation at low loads. So those were the key recommendations from an operational side. And having done the successfully conducted the low load test runs at Moda and Ukai, we did 40% minimum technical minimum. We achieved that low load over a sustained period of time without any secondary fuel oil consumption, without making any changes to the design of the existing equipment. and that essentially resulted in us coming out with a document on low load RAM test procedures, which essentially provides you a glimpse of the preparatory activities that a unit 200 or a 500 megawatt unit should adopt before going for a test run, and then how the test run should be conducted. So this particular document has already been released in public domain in April 2020, and it can be found out on our website gtgindia.com. The next set of recommendation is both the recommendations are very important from a scalability perspective. The pilots that we did for NTPC and GSECL have already demonstrated that Indian units are capable to take up flexible operations. They are capable of cycling with minimal changes to the operational procedures and minimal capex investment requirement. However, this needs to be scaled up at a large scale basis, with more generating units, utilities from other states participating. NTPC has already started doing that in most of its plants. This scaling up activity requires not only looking at reviewing the operational practices that have been prevalent in those units, but also handholding of the training of the plant operators, because irrespective of whether you have a system in place, if the plant operator is not confident of running the unit at a low load, which he has been running at base load for the last 30 years, it's very difficult. And this is something which came out through the various workshops and knowledge dissemination events that we did over the last 4 years. We had close to more than 10 workshops and boot camps delivered with the support of USAID and USEA. And of course, we continue to do with this knowledge dissemination through various webinars. We have a couple of workshops planned in the regional workshops planned in the coming year, where we are going to do that. But having said that, capacity building happens to be the activity which should be continued over the next 4-5 years before the Indian coal generating plants achieve this this capability. Next slide, please. Just to sum up, the way forward is on the implementation side, NTPC and GSECL both have started looking at implementing flexibility in a phase-wise manner. What we would recommend is more state utilities join this bandwagon and take it up as a practice in their plans. We understand that there is already a committee constituted by CE, a task force committee, which has an identified list of stations where test runs are to be conducted, and some have already been conducted. The low load test run procedures, as I mentioned, these are available for public dissemination and outreach. We would honestly request whosoever is interested to look at the link, review them, download and share it within their network, and utilize those recommendations. And of course, there has to be more stakeholder consultations on the cost compensation for flexible operations. This is very much necessary because most of the utilities have already started facing the issue of low loads due to increased RE penetration. However, there is not an enabling regulatory framework either at the central level or at the state level to adequately compensate these stations. And as I mentioned earlier, capacity building and handholding of plant operators and the management should be continued at the state utility level. So that's all what the summary report document comprises of. I will now request Mr. A.K. Sinha to briefly talk about the recipe book on flexible operations. Over to you, sir.
Thank you, Anuj. And good afternoon, everybody. Before I talk about the book, let me take this opportunity to just switch on my video. Let me take this opportunity to thank all the reviewers and for their support in preparing this book. Before that, I'll talk about the brief background, because how this all started. Actually, the Indian journey towards flexibilization really started on exact date is 19th May 2016, with the formation of the Special Task Force on Flexibilization. And we are fortunate to have the founding chairman of the task force, K.K. Sharma sir. He's here. And congratulations, sir. We have taken it a long way. We also have with us Mr. Prakash Tiwari. He is also there, followed by, he was also the chairman of the task force, and he kept the momentum alive and he took that initiative further. And now we have the present chairman, Mr. Ramesh Babu. He's heading this task force. Subsequently, in 2017, USAID also joined this initiative. And we had seen a lot of participations of international players like EPRI, Intertech, then all the OEMs, GE, Siemens. And it was a great process. It was a great learning. We had a number of workshops, international experiences, exchange programs where we actually visited the plants in US and Germany, because I personally visited more than around 15, 16 plants in US and Germany. So how they operate the plants and what are the Indian conditions. I would especially like to thank Mr. Tobias Winter. He's also there for his continuous encouragement and unconditional support. In fact, the idea of putting out the experience in the form of a recipe book was his. That let me admit here. Because see, we have seen that unless knowledge is documented, it gets lost. A lot of experiences, we have had workshops, more than 50 to 60 workshops in last few years, 2-3 years. And a number of presentations are there. So from each of these, we have been jotting down things and putting it, and all these things I put it together during this COVID. So COVID that provided me an opportunity for that also. And again, I'm also fortunate to have the support of USAID and our GTG colleagues, including Monali, Michael Satin. They have always stood by me. Together, we have made a lot of things happen actually in the sector. So on the reverse side, I'd like to thank Dr. Claudia Wise for VGB, Maggie Waitrose, and Dr. Colin Henderson, IEA. They have provided a very meticulous review and provided very valuable inputs for the study, for this report. And Mr. Stephen Storm from EPRI, Mr. Nikhil Kumar from Intertech, Doug, and then GE Siemens from NTPC, Mr. Vinay Kumar. And there have been a lot of insightful discussions with different plants. I'd contacted more than 25 stations to collect data, information, how, what are the challenges that stations are facing. To mention a few names, Mr. Banerjee from NTPC is there, Mr. A.K. Pandey, Ratnesh, Mr. Gandhi from GSECL. So on the book, it includes number of chapters. So I'll mention the first thing is safety. It's a separate chapter. We don't find it anywhere. And this will be a very important factor when you run your units on a flexible mode. Because see, even this year also we had seen 2 explosions in India. And in the past also we have seen. So that is the most important aspect as per me. So a separate chapter and with the findings, international findings. Actually, I collected all the data from all these happenings in the past, furnace explosions, bottom mass explosions, and then prepared this. Refer to the documents. There's a separate chapter on damage modeling, damage mechanisms, then review of operating practices, then what are the strategies for unlocking this flexibilization. There's a chapter on part load efficiency, then optimization of startup cost. Then we have done number of pilot studies. Actually, some of the pilot studies that was not mentioned, it started with Dadri. 2 pilot studies are ongoing in DVC and Maithan with IGF. Then with GTG-RISE, we had done at Ukai in Mauda, and then one is planned in KPCL, Bellary. So all those learnings, we had, that was great learning for the Indian context. So I tried to put all those learnings in this book. What are the retrofit options? Then there's another chapter on layer practice. This is very important because when you run your units, and many of the units you have seen, they are under long shutdowns. Even for short shutdown also, this is very important. Combustion optimization is again a separate chapter, and then best international practices. Next slide. So the approach of this book, actually, it has a general applicability, but I have tried to customize it for the Indian context, because see, it's very different. The way you operate your plant, it depends upon the context of your market, the type of coal that you have, the training level of your operators. Because today, honestly, we don't have a simulator which trains engineers for flexible operation. For the market also, I've seen plants in Germany, the way they operate. For example, I'll give you one example. They reduce the load by operating their HPLP bypass, because there's a market offers them money for that. And to get that money, you can operate even by burning that coal. But in India, you cannot afford that, because even if you reduce the load, you'll still be burning that much coal. So as for the market context, you have to customize your operating procedures. So it was based on detailed literature review. I've done this literature review over the last 3 years. Then I had sent questionnaires, one-to-one discussions with over 25 stations. Referred to different international stations, visits to Duke Energy, Excel. This I did under USAID, Uniper, RWE, VGB with IGF support. Then we had inputs from experts like NG Lab, J-Coal was also there, G, Siemens, BHL, EPRI was there. All those findings, I tried to put it in the Indian context in that book. So I think this should be useful for the plant operators and for the plant engineers. Next slide. And this is part of my book. This is the only one that I've taken to show you that how this book will be important for you. For example, if you see here, like today, you are operating your units here, like with no business as usual. And tomorrow you want to make some changes. So simply by altering your operational procedures, operational practices, you can reduce your cost. This is the cost, operational cost with different modes of operations. So simply by altering your operational procedures, you'll be able to reduce your cost. And the potential is huge. So you can, and this is a range that I have given. We have done some analysis on this, actual analysis on the cost. So it doesn't matter how you achieve your flexibility. But if you achieve it at the minimum cost, then that's worth it, because tomorrow cost will decide. Maybe if you are not able to do it at a lower cost, tomorrow battery will take over this flexibilization market. So cost is a very important factor. And again, the way you operate your units, that will decide your cost. Then with minimum changes that Ramesh sir was mentioning, that we are going for advanced process control and other things with C&I interventions. That is the next least cost actions that needs to be taken. And then as you go down here, the cost increases, cost of implementation is there. Although your operational cost will reduce, but again, this is a huge upfront cost, and you'll have to see on cost benefit analysis. So this book will provide you a lot of insights in how to reduce your operational cost, how to improve your safety and other things. I think that's all, thanks. And this book will be available free of cost. That is a gift from us to the sector. And however, if somebody still wants to pay, there will be an option on Amazon with an option with a token fee. You can make a payment, and that payment will go directly to the Prime Minister's Relief Fund. And after paying that, you can download that book. But however, if you don't want to pay that, you can still have it for free. Thank you.
Thank you so much, Mr. Sinha. Thank you for giving us a teaser of the report and also for the information on the availability of the report. So we are now ready to release the report, and the two reports which we are releasing. I would request, or I would seek the permission of Mr. Devangan and Karen. Do we have the permission to release the report? Mr. Devangan and Karen.
Yes, Monali.
Can we go ahead?
We're delighted to have this released.
Thank you so much. So we'll
Yes, Monali.
Thank you, Karen. Thank you, Mr. Devangan. We'll do a virtual release. So, yeah, Ripu. Thank you so much. So this is how we have to manage the release in the virtual world. But Thank you so much. Both these reports would be available on the GTG-RISE website, and as was mentioned by the speakers. I would, before we start the panel discussion, I would now request all our members to please switch on their cameras so that we can do one quick photo op. Can we request all the speakers, panel members, everybody to please switch on your cameras so that we can take a quick, and please smile for the cameras. Ripu, just signal us once you're done. Okay, thank you so much. Thank you so much. Thank you so much for your time and everyone, and thank you so much for your kind words, Karen, Ms. Devangan, and Mr. Babu. We'll now move on to the main, we'll also now move on to the part where everybody is waiting excitedly for the panel discussion, and my colleague Shubhranshu, Senior Advisor, USAID GTG-RISE Initiative and partner Deloitte India would be moderating this session. So over to you, Shubhranshu.
Thank you so much, Manali. So let me start by introducing the first panelist, Dr. Winfried Damm, Director, Indo-German Energy Program at GiZ, Germany in India, primarily. Dr. Damm is a highly respected professional in the utility space. He's worked in a municipal utility stat work in Leipzig in Germany, is a graduate and MBA and then a PhD from FU Berlin. So fairly well recognized in India. He's been here since 2014 and very knowledgeable in the integration of renewables in particular, which he grappled with as part of the utility and also as part of the German industry for a while. So Dr. Damm, if I can start with you, sir. Given your experience of integrating large amounts of renewables onto the grid, and Germany's experience, I should say, what are the key challenges that you grappled with from a conventional generator's perspective? How did you contend with conventional generators' flexibility to manage high levels of RE integration onto the grid? If you could walk us through that, that would be very useful for the participants.
Thank you very much for the nice introduction. I prepared a few slides to give a broader answer. Yes, and let me start off reflecting. What are we talking about and why? And if you follow on the next page already. Yes, that's an overview from the US. So you can see despite all the political support, for the last 10 years, coal is declining. And it's more or less halving the production. Going alongside, the PLF of coal is being reduced from 67% to 48% only last year. And this all despite of generation costs just above 2 US cents, which is about 1.6 rupee per unit. On the next page, you can see what's happening in Germany. This is, and as you see in the middle, this is a black hard coal, the brown is lignite. And as you can see on the right side, if we're moving to Gandhi's birthday, October 2nd, you can see how fast and how strong the ramping is happening of hard coal. Even lignite has to ramp, and even nuclear has to ramp due to amounts of wind and solar, which are the upper green and yellow things. So you see, that's the future. And if you move on the next slide, just some number playing around right now, India is requiring or is generating nearly 1,400 terawatt hours a year, last fiscal. If you assume that PV produces about 1,400 kilowatt hours from 1 kV, it's a simply math that you would say if the demand, the electricity demand increases by 3%, India would need additional 30 gigawatt of PV annually. If you're more optimistic and say electricity demand increased by 5%, just for the increase, you need 50 gigawatt annually. Just think what this will happen to the ramp rates and the pressure on coal. So let's move on to the next page. And you see, these are already numbers from India. So in Karnataka, we have a maximum penetration of up to 90% and maximum daily operations on top of 50%. In Germany, for this year only, starting 1st of January till yesterday, we had an average of 52% electricity production from renewables only. On the next page, we can see what is the main thing to achieve. And when the sun is not shining, the ramp up and down, or it is not shining, ramp up of the existing coal plants, which is India's biggest energy storage, is the thing to do. On the next page, you see what can be achieved. So these are numbers from the German association, and I have to thank Mr. Tain, who is with us and will be on the panel with all his major support, according with Mrs. Weise, for the last years which is happening. And we have to share our experience because we have to learn from the mistakes we did in Germany. And I don't want to have the same mistakes repeated in India. So we are so much delighted that your government, Joint Secretary Devanjan, took this issue up so seriously. And let me also thank especially NTPC and Mr. Ramesh Babu, Director Operations of NTPC, for the trust your organization has shared with us over all those years. We are now looking back to success stories, but we are also looking forward to a lot of work in which all of us will be involved. The technical feasibility has been proven, but sadly, I have to admit, the hard part is still ahead of us. And one important aspect which remains to be solved is the economic viability. Another important task ahead is to bring all those thousands of plant operators in this country on the same page. Some are already in, but trainings on simulators are required, trainings as such in operating these plants is required, and as of now, baseload operators have to become expert in flexibility. And we would propose to call them flexperts. If these tasks which lay ahead of us, which require combined effort of the ministry, NTPC, and all the Indian leaders in power plants operations, the state operators and generators, but also the power plant associations like EEC and development agencies like USAID and ourselves, GiZ, to reach out to the operators of these plants. Mr. KK Sharma is also here with us today. I was told that you actually visited most, if not all, of the plants. You were in charge of and to connect to the people. And despite this might be more difficult in times of Corona, this actually shows how important it is to connect to the people who have to implement what we are talking here on the ground, and where all of this becomes a sometimes harsh reality. I remember Mr. Malik from CEA and Mr. Sinha saying, we have created an army of baseload operators who now have to be prepared for completely different scenarios with high shares of renewables now. And I demonstrated what the tasks are coming up in the future, and there's no way back. We believe this is the most challenging part now, to get the operators on board and prepare them for the future, for the vision of Prime Minister Modi's of India, with extremely high shares of renewables, longing and looking for at least 450 gigawatts till 2030. This is why we are so thankful for Mr. Sinha of having aggregated all the learnings from his own personal journey in his recipe book, which has been just launched. And I admit that you are lucky to get such a book for free. If you would ask for similar books in Germany, and you can ask Ms. Katen, they're extremely expensive to acquire and get hold of them. because there's all the rich experience of such highly qualified people who have been in touch with the operators on the ground and are considering what are the real things to be done. So thank you, Mr. Sinha, so much for this important contribution to the nation. And let me once again assure all of you that GIZ and the Indo-German Energy Forum, and I'm glad that Mr. Winter is here, who pushed all this, are fully committed to accompany India on this important journey. We and everyone in the sector need to react proactively. Don't wait till your power plant is forced to shut down due to inflexibility. You still have the chance proactively to get those things changed and make sure you are able to ramp down, as I demonstrated here, to levels at least 40%, but most likely much lower than that. And I look pretty much forward to interact with all of you and discuss how we can further support you on this journey. Dhanyavad. Thank you.
Thank you. Thanks so much, Dr. Dam. 40% PMIN, 5% ramping rate, those would be good targets to aim for India. So thank you very much for walking us through those experiences. Let me introduce the rest of the panel to start with, and then we'll have a round of questions for each one of them before we open it up for some audience questions as well. So we have Dr. Oliver Then, Executive Managing Director of VGB Power Tech with us. He's been involved in studies in India. He's no stranger to India. He's actually visited quite a few plants in India as well. So we will pose him some questions on preparedness as that he has assessed in the Indian environment. Mr. V. Ponnuraj, Senior ICE Officer and Managing Director of KPCL. Mr. Ponnuraj, thank you for joining us, sparing time to join us. An important partner KPCL is for the RISE program. We're doing a number of pilots with them. And of course, on this particular subject also, I know for a fact that Mr. Ponnuraj is very passionate about introducing flexibility and making plants flexible. So we will have questions for him. Mr. Vinay Kumar, Executive Director, NTPC, Executive Director, Engineering at NTPC. Thank you for joining us also, sir. Mr. B.C. Mahalik, again, no stranger to the topic, as well as, of course, to the program as well. He's been at the forefront of CEA's Flexibilization Initiative with a very important report which got released last year. So, Mr. Mahalik, thank you for joining us. He's Chief Engineering at CEA. Mr. H.N. Baxi, Managing Director at GSECL. Again, a very important partner for the program, for the RISE program. We've had a pilot journey with GTCL also, so there'll be, I'm sure, quite a few important things to share from the pilot itself. So let me start with Dr. Then. Dr. Then, as I said, you've been doing the rounds of quite a few Indian generating stations as well, and you've carried out studies in the Indian environment. What is the assessment on the level of preparedness of the units for flexible operations? How much distance do we have to travel?
Thank you, Mr. Patnaik. I hope you can hear me.
Yes, please.
First, thank you very much for the invitation to be part of this high-level event and to see all the honorable people around which have been at our side, mostly for a couple of years, since we as VGB, as an international association, have been a proud partner in the Indian journey to more renewable integrate, to more green power generation, and by this, the need for flexibilization of thermal power plants. And we have been part of this flexibility task force now for a couple of years, which has been set up, as it was already mentioned by the Honorable K.K. Sharma from NTPC. Under his wise guidance, we started all these steps, and we started the journey in this program together with Dr. Dam also being member of this task force from the very beginning, and colleagues from EEC, from POSOCO and others have been part and are still part of this flexibility task force. So we are also very happy to be there. Now under the guidance of Mr. Babu, I think we have to make the next steps. Regarding the issue of the preparedness and our experience in the Indian power sector, I would like to say that preparedness in this environment for me has 4 dimensions, which needs to be covered to come to a conclusion as how somebody is prepared for operating flexible in the market. The first dimension is the technical issue. So it's a matter of the equipment, of the power plant technologies involved. And we have seen big differences in the Indian power fleet, as it is usual for any kind of power fleet in the world, or at least for most of the countries. You know, we have a fleet of a very different age, very different sizes of units. We have a lot of subcritical units. We have supercritical units. We have now seen the first ultra supercritical units coming online. And of course, this is very much influencing the type of equipment, the technology available when you think about flexibility. And of course, this has to be evaluated on a very individual basis. And I think this is the reason for the lot of pilot projects we are seeing, you know, whether they are under the guidance, auspices of our flexibility task force, or the USAID program, or JCOL, or others. It has to be looked at on a very individual basis, because each and every power plant is a unique piece of equipment. And if you are lucky, you can roll out a lot of the findings made in one individual unit, at least to a certain amount, a certain number of units, some kind of subfleet. And this is, I think, what we all intend. And that is also the reason, and that was one of the questions in the chat, why we have chosen the pilot plants as we have done it. The second dimension for being prepared is the operational dimension, and that is covering all your operation and maintenance procedures and processes, etc., that are in place. And that is highly affected by the awareness and the skill level of all the people involved. And that is what Dr. Dam meant with, we have a fleet of baseload operators which now being turned or need to be turned into flexperts, which are able to run and operate the units in a flexible way. And I come to this later. So training, therefore, is a very essential for addressing these operational dimension of things. The third dimension I will cover only shortly. It's the market design dimension. Of course, for flexibilization, you need a business case. You need, and this is set up by the market design, by the regulation. This has in particular not been our part in the task force, but I know that others are involved, because it goes then up to the governmental level, who sets in the end the rules and regulations and the market design for addressing and ensuring that flexibility is getting a value and is able to set up a business case for flexibilization measures. And the last but not least, the fourth dimension from my perspective is the mindset. That mindset that you need all over the industry to be aware of these flexibility issues. And I remember when we started my first visit in India six years ago, and I showed a slide with the different steps of priorities in the European power sector. And I stated, finally, flexibility has overturned efficiency as the #1 priority for each and every activity we are doing in the power industry, as such as coal and gas fired power plants are addressed, and even nuclear by that time. So, and it came as a surprise. And I think over the last couple of years, we all have been able to turn around this surprise into a challenge that is really actively taken by everybody in the power sector in India. And I think this is a huge effort from the first slides with flexibility and you know, I don't know the English word when you make like this, to really seeing, well, this should also become our #1 priority. And as such, we have seen a huge effort of all, a huge success regarding all our efforts. And a lot of other Indian operators have started now their activities with and investigations with regard to flexibility. This is really interesting, and will be interesting to see when we address new technologies, so supercritical plants and also the newest ultra supercritical plants, what we can achieve with regards to flexibility in this sense. But I think the basis has been laid very successfully, and now we have to build up the next steps on that. Thank you.
Thank you so much, Dr. Ten. Let me come to Mr. Malik next. Mr. Malik, you know, you've been the nodal agency, of course, for driving flexible operations in the country. I think most people would be unaware of the initiatives that's otherwise being taken at the national level. So if you could walk us through what is the level of preparedness that you've assessed, and what are the steps that's underway in terms of driving flexibilization, both at the center and the state level, sir?
Thank you. First of all, I like to thank Mr. Anjan Sinha and USAID for offering such type of books in our power sector. Thank you. Actually, it is just started. It is the we have started the fleet total number of this. 1/3. Actually, Debangan, our JS already briefed that we have a total fleet 200 plus gigawatt, and almost 1/3 of that, about 66 gigawatt is required to actually very flexible mode. They may operate up to 40 to 45% load, and remaining units have to be a low level of flexibility, that's like 50 to 55%. Otherwise, our actually assessments says that in 2022, when the 170 gigawatt, 175 gigawatt, that renewable sources integration will be happened, when that time our flexible power is required to balance the grid. We have seen that if we go as far business as usual, we have to back down, means minimum load. Our thermal units, the faced may up to 26%. So we require coordinated efforts like support from the hydro, especially from the state hydro. We know that this state hydro are running continuously in some states from, and if we offer some price for the this flexible power when it is required during the evening peak or some other time, except when solar energy is there. Just like we are talking about the power special price for the thermal flexible power, we should look into the power this hydropower also. Where if hydropower power supply in this period during the peak hours when the solar power is not available, then state may think other ways. They can purchase power from the grid during the other times, and they may supply the power in the evening time so that they have some profit. In this way, we have to think. That means the flexible power, it may be from hydro and thermal. We should have separate tariff for that. That is the one thinking is going on. Another is the, this is the national perspective. We have to see from the national level. Suppose in one state, they have RE state, they have minimum thermal power plant and maximum solar or wind generation is there. So they cannot manage, this cannot be managed within non-state. So we have to take the support from the other state where renewable energy is minimum. These two things we have to see. Another thing, we have to see that the pump storage. We have to see the geographical location in India such that where it is possible to operate in solar, wind and pump storage in a combination. Otherwise, what happened? We have to balance the grid. To balance the grid, we have to see the battery. We have to install battery, or we have to go this thermal power have to stress below 40%, or anything like this, or have to be curtail the this have to be cut down this curtailment of the this solar or wind generation, RE generation, that has to be taken to manage this grid. These things have already started in discussion, and we have accordingly identified few units in consultation with states and already tested a low load operation like 40% and successfully operated at 3% RAM rate. Especially we can say that in Dadri, NTPC and Vindhyachal, also in Sagar Dighi, West Bengal, in Ukai, in Gujarat, like this. Many more are units are in pipeline in this test. Once it is, we have to go long ways. That I told that 1/3 of the fleet, about 60 gigawatt plus unit, have to be very flexible in operation. So it is already, it is the initial state only. We have to go in long way.
Right. Thank you so much. Thanks, Mr. Malik. Let me come to Mr. Ponuraj next. Sir, Karnataka, of course, has been, is an RE-rich state, has been adding capacity significantly. And you also we all went through the COVID period when we saw a drop in demand, at least temporarily for the first 2-3 months. What has been your experience on the demands for flexibility of your thermal fleet? Did you experience significant demands on flexing your thermal fleet? And if you can walk us through that, sir.
Yeah, thanks, Branshu. When you were introducing me in the beginning about participating in this program, you talked about me being enthusiastic about flexibilization. And I'm not sure whether I'm enthusiastic or not, but writing for us on the wall is very clear that our time for thermal is over, and it is time for RE, and that's what is happening in Karnataka. If I had to give you simple data about why I'm saying this, yesterday, for example, at 14 hours, the total state demand was about 6,691 megawatt, of which 5,300 came from renewable energy. About 1,800 came from hydel, which means we were the so-called RE. If you put the hydel also together, then it was about 500 megawatt, in excess of what was the total consumption at that point of time. So now you can understand whether I can be enthusiastic or I need not be enthusiastic. I mean, we are already being pushed and we have to be there. So our strategy now is that flexibilize for some time and then phase out after some time. And probably we will have to take cue from Germany, which is already having a plan for phasing out thermal power plants over a period of time. So I think it's time for us to think on those lines, taking into consideration technical possibilities of balancing the grid during the transition period. And then as well as looking at the cost of retiring the plants. I mean, if I retire the plant, there are debts associated with it, the manpower associated with it, and then the costs to be borne. So all that will have to be thought about. So we are probably, what I would think is that even one step ahead of flexibilization, we may also have to think about phasing out the thermal power plants rather than only limiting ourselves to flexibilization. But then, having said that, it's high time for us to think about flexibilization. So the experiment which, or the piloting which we're trying to do with the help of USAID and CEA, it's in the right direction. So we are participating in this program. In fact, when this proposal came, I was asking our people, our team, and as well as the USAID team, that it should have been done much earlier. Probably along with Gujarat itself, we should have taken up this exercise, so that by this time we would have clearly understood what we need to do in the next 4 or 5 years to come. So that's a situation. For example, if you look at the last year, 2019-20, and this year, the total consumption, contribution from the RE sector was 31% last year. This year, already for the period up to yesterday, it is already 39, close to 40%. So we are nowhere behind Germany. I mean, if you only take Karnataka, I think we are close to being catching up with Germany in all respects as far as RE is concerned. So this is the scenario as on today. So we are very much on the track of having to flexibilize our thermal power plants. At the point at this moment is that, as I should actually compliment Mr. Sinha, having brought out about how we can go about flexibilization. Initially, you can do a lot of things by even improving your operational practices. Then you can look at a bit of training our manpower, and then improving the flexibilization. After that, we may have to look at automation as well as investment in machineries also, in case if you have to go below 40%. So that comes at a cost. Now, I was looking at the cost estimation by the CEA, which was the document which was released last year. If you look at the cost, both OPEX as well as CAPEX, in case if you have to go below 40% of load, then it comes to close to about 80 paise to 1 rupee per unit of cost of generation. So already thermal power plants are having the total cost of about 4 rupees per unit. If we add 1 rupee, then clearly thermal power will be out of the market and out of the favor of all the ESCOMs. So we are definitely looking at flexibilization, and hopefully we would be able to manage this transition with flexibilization, and probably then we will look up to Germany to give us lessons on phasing out as well.
Thank you so much, sir. Alarming numbers there, but puts us in perspective. You lead the way, but whole of India would be somewhere similar in a few years' time, I'm sure. So over to, maybe let me come to Mr. Vinay Kumar next, and then we'll come back, save the last for Mr. Baxi, given that he will have some pilot experiences to share. Mr. Kumar, I wanted to, since everyone is talking about technical challenges, I thought I'll slightly change it. I know you come from a significant technical background, but you're also looking at what are the commercial and regulatory challenges for implementing flexibility. So while we've spoken about the technical challenges, what in your assessment is required from a commercial and regulatory standpoint to make sure that we are actually investing and making our plans flexible? If you can throw some light on that, sir. Mr. Kumar, you're on mute.
Good evening to everybody. I am thankful to the organizers who made me the part of this event, and thank to USAID, Indo-German Energy Forum, NG Labs, who have conducted various pilots in the country and in NTPC also, to make us aware about this flexibilization. Then special thanks to Mr. Anjan Sinha for this recipe book on the flexibilization, which will help operating engineers in a good way of coal-fired power plants. And this is an interesting book for designers also, so that they can use this data in their futuristic design of thermal power plants. In NTPC, we have a tendency to match with the world. So I think from past 20 to 25 years, we are asking the power plant manufacturers to provide us power plant which should be capable of 2-shift operations. Then we were asking the control range from 50 to 100%, in which steam temperature variation should not be there. And we have conducted this proof of concept in one of the stations, and we are hopeful this will be a long way for us to make our power plants flexible. Now I will come to this the real question put up by Mr. Subhranshu Patnaik, that what are the commercial and regulatory aspects. So the flexibilization will certainly reduce the heat rate. It will increase the auxiliary power consumption. This will put the plant, this will put a challenge to plant to operate in the safe mode. Then the outages will be more, because flexible operation will create the thermal fatigue loads for the important turbine and boiler components. So all this will lead to outages, increase the force outages. Then even this shutdowns, frequent startups will lead to the startup cost. And all these force shutdown will will force the power plant engineers to be on toes, to keep to investigate where things may go wrong, and and how to correct the plants. Like we are now putting our power plants, which will indicate the new plants, which will indicate the residual life of important component. Then I think in general, power plants will have to do better mapping during annual shutdown and overhauls, so that they can know the health of their pressure part components, which will be subjected to failure due to large number of flexible cycles. And certainly, as this commercial and regulatory challenges are, that the regulatory commission will have to find out how much should be compensated. Still, there are some compensation available for part load operations, but when it will be too much flexible, then it has to be inbuilt in the system. Otherwise, it will be difficult to bear the cost by power plant operators. So this aspect has to be seen in detail. And like Anjan Sinha told, he has worked out what is the cost. And we are also because lots of power plants are undergoing these flexible operations, we are keeping watch on them. We are selecting the plants which are subjected to more flexible operation for retrofitting with the advanced process control and some hardware fittings, so that it can be operated in better way. So we are keeping a watch on our O&M cost also, so that we will be able to know how much compensation is required. So, but I think lots of power plants which are sick or they are not able to operate, they are not getting the load. For them, this is an opportunity also, because if they convert to this flexible operation, then they can be the part of generation, and I think their financial health can change also. So all these aspects will be there, and we are constantly doing this policy advocacy, and so that it is suitable for all these power generators. And I will I will call all the power generators from state utilities, IPPs. They should change themselves for the new challenges. But in India, what is there? It is not like Europe, America, and other countries where lots of gas reserves are there, which can do the balancing in the grid. In India, because we are dependent on coal, only coal and nuclear can be used for the balancing, because other resources we do not have. So it is not that the days for coal-fired thermal power plants are over. Coal-fired thermal power plants have to adopt clean coal technology and be ready for the flexibilization. And if the energy demands increase, it can be beneficial to us also. And that is my submissions. Thank you, Subhranshu.
Thank you so much, sir. Now let me come to Mr. Baxi. A very good evening. Thank you for waiting patiently, sir. We thought we'll take you last so that you share some of the experiences of the pilot, what you learned from the pilot studies, and also the low load testing at Ukai, and also share what are the enablers that you see for making flexible investments happen at your power plants. So if you can walk us through that, Mr. Baxi.
Yeah, good evening. First of all, very much thankful to USAID GTG-RISE program, having GSECL as a partner in the pilot program for the flexible operation of the thermal power plant. Regarding the pilot project, from the pilot project, we have got a much more confidence what we were not at that earlier. Because all the coal plant, particularly Gujarat, is also reached renewable state. So we were almost every day we can say we are backing down an RSD, and we are starting in unit in within the 12 hours, within 24 hours. And that because of the experience, we could take our own trial for other 8 units for the flexible operation. And I think most of the unit we could succeed, and parameters are also within the normal range. Regarding, we are also thinking to have a flexible operation of a gas plant, particularly in our one of the unit at Uttran. And further also, in we have a 2 unit we have retrofitted in Uka and Vadarbori. In near future, we are planning to have a 2 unit further retrofitted with the flexible operation also. So because of this flexible operation, we are trying to do best possible thing, but the major concern is the policy and the cost compensation. It is a most required at present, so we can all invest the more money to have a more flexible operation. Thank you.
Thank you so much, Mr. Baxi. I think we've completely run out of time, we've actually overshot time, and Mr. Devangan also had to leave. But if we have time, if there are any questions from the audience, then we could take that up. So let me just quickly see if we have.
You have answered all these questions. I was typing these questions.
Okay. All right. So that's
by Mr. Ravi Sitapati. He wanted Dr. Dam's presentation.
We'll send that. We will, of course.
So I haven't answered because he had referred it to Dr. Dam, but I believe we can send it. So apart from there may be some questions, or you may not be satisfied with my answers. So you can ask me. I'll answer, or any of the panelists or anybody. I think there were 11 questions and I answered all.
All right. Thank you. Thanks. Then we'll hand it over to Monali for a vote of thanks and bring this session then to a close. Monali, over to you.
Thank you so much, Shubhranshu. Great discussion. Thoroughly enjoyed all the panel members, and unfortunately we ran out of time. It would have been great to hear more from all the panel members, but hopefully we'll have another opportunities to hear all of you. So I'll quickly, since we are out of time, I'll quickly run over the vote of thanks, and it would be kind of fast one, thanking everybody. But I'll start with Mr. Devangan and Mr. Suman in Ministry of Power, and also to Ministry of Power. Thank you so much for all the support and cooperation extended to USAID GTG-RISE. I would also like to acknowledge and thank Mr. KP Sharma, Mr. Prakash Tiwari, who were involved in the GTG-RISE initially and when we started this initiative or this pilot. I would like to thank Mr. Babu for continuing that partnership, for the support extended to us, Mr. Banerjee at NTPC and the entire team there. Also many thanks to Mr. Bakshi, Mr. Gandhi at GCL, GSECL for their cooperation extended to the GTG-RISE project. I would also like to thank Mr. Punnuraj and his team at KPCL. We are currently working with you, with your team, sir, and we are thoroughly enjoying it, and we look forward to taking this to a logical conclusion. I would like to thank Mr. Malik and his team at CA. You've always been very supportive of the GTG-RISE project, and we look forward to continuing our partnership and supporting CA as we move forward with this pilot. I would also like to thank Dr. Dam and IGF for this cooperation and the extensive work which you have been doing in this area. Mr. Tobias as well. I don't know if he's on the call or not. Dr. Pan and the other panel members, if I missed any. I would finally like to thank the Deloitte team, Mr. Sinha, Shubhranshu, Anuj, and other team members for putting up this great, excellent panel discussion and the report release. I would like to thank Karen for, taking time off on Friday evening and joining us today. So thank you so much, Karen. And most importantly, thank you, ladies and gentlemen, for joining us today. As we mentioned, we will be circulating the presentation recordings, the presentation including Dr. Dam's, as well as the other presentations which were made. The reports will be uploaded on the GTG website. Please do check it out, and we will try to respond. If Mr. Sinha has missed any question, we'll try and respond back to them. So thank you for joining us today, and have a very good evening. And thanks to all the people who have joined from US as well. Thank you so much.
Thank you.
Thank you. Bye.
Thank you.
Thank you so much.
Thank you.
Thank you. Thank you all.
Thank you. Thank you, Dr. Dan. That's very good.
Thanks from KPCL. Thank you.
Thank you so much. Thank you so much.
Thank you. Thank you, sir.
And congratulations, Mr. Sinha.
Congratulations, Sinha, sir.
For the release.
Thank you all. Thank you so much.
I was short and crisp because I was watching the time, but I don't think that I crossed the time because
I think it went well. Thank you so much.
Yeah.
Thank you. I'll stop the recording now.
Sure. And thank you, Mr. Malik. Thank you,
Thank you.
Dr. Khan.